Hello guys, and welcome back to my YouTube channel. So far we've learned what functions are, their types and relations. But here's a question. What if you apply one function and then another function right after? Or what if you want to reverse a function to get back to your original input? That's exactly what today's lesson is about. That is composition of functions and inverse functions. Okay, so let's start with composition of functions. Composition of functions. Okay, if you have two functions, let's say f and g, then if you want to write the composition of this function, it's going to be written as f of g of x, or you can also write it as f into g of x. Okay, when I write it like this simply means first you apply g to x. You apply g to x and then you apply f to the results. So we first of all do g of x and then we continue with f of g of x. Okay, let me give you guys a quick example in order to understand better. Okay, let's have an example. Let's say let f of x be equal to 2x, and then let's just have g of x equal to x plus 3. I'm just giving a very rough example. Okay, if we want to have f of g of x, then remember I earlier said we take g of x and apply it, and then we apply f to the result. Okay, so from the equation we know that our g of x is x plus 3, and so we are going to have f of x plus 3. This is f of g of x. Since our f of x is 2x, our f of x is 2x, so we are going to have 2 into x plus 3. Remember, we are replacing x with g of x. So we are going to have 2 into x plus 3. So what does this give us? It gives us 2x plus 6. And this is what we have. Okay, let's take another one. If we have g of x, it's going to be g into f of x, which is g into 2x. And what are we going to have? Our g of x is x plus 3, so we're just going to substitute it. That is 2x plus 3. So this is what we have. And we need to take note. F, sorry, f of g of x is not equal to g of f of x. We need to notice that composition is not always commutative. So as we can see from here, they were not equal. This is our f of x, this is our f of g of x here, and this is our g of f of x here. And as you can see, they were not commutative. So let's just have another quick example. That is, let's say f of x is equal to x squared and g of x is equal to x plus 1. Okay, now let's find f of g of x and g of f of x. So let's take the first case, f of g of x. So we are going to have x plus 1, all that squared. Remember, we are replacing g of x with x in f of x. So that is why we have x plus 1, all that square. Okay, and what does this give us? We have x plus 1, x plus 1. Here, this is just a quick multiplication. That is x squared plus x plus x plus 1, which is x squared plus 2x plus 1. So this is what we have when we take f of g of x. So let's take the other case, that is g of f of x. Let's take this case. Okay, here we are going to be having x squared plus 1. So this is what we're going to be having. Remember, we are replacing f of x in g of x. That is why we have x squared plus 1. So this is what we have. And as I earlier said, composition is not commutative. That is why we are having different answers for f of g of x and g of f of x. Okay, now let's talk about the inverse of a function. So now I'm moving to inverse of a function. Okay, the inverse of a function simply reverses what the function has done. So let's say if f maps x to y, then the inverse that is f inverse should map y to x. So we need to take note that not all functions have inverses, only one-to-one functions have inverses. So these are just simply the steps to find the inverse. First, we need to write y equal to f of x. That is the first step to find the inverse. Secondly, we need to swap x and y. Thirdly, we need to solve for y. And fourthly, we now rename y as f inverse of x. Okay, so let's take an example to illustrate this. So let's have an example. Let's say f of x is equal to 2x plus 3. So we have our first step. Our first step says write y equal to f of x. So since f of x is 2x plus 3, we are going to have y equal to 2x plus 3. This is our first step. Our second step says swap x and y. That is, we need to just simply make x the subject of our formula. So normally we have it this way. We are just going to take x this way and bring y over here. So from there we are going to have minus 2x equal to 3 minus y. This is what we are going to be having. Okay, so here we're going to divide both sides by minus 2. Here we simply cancel, and then we are going to have x equal to minus 3 plus y on 2. So let me just simplify further, which will be y minus 3 on 2. Okay, so that is what we are going to be having. And the last step simply says rename y as f inverse of x. So here we're just going to change this. We're going to have f inverse of x equal to, we'll just replace this with x, which will be x minus 3 on 2. So that is how we find the inverse of a function. Okay, so how do we check if two functions are inverses? Let's say f and g are inverses if f of g of x is equal to x and g of f of x is also equals to x. Now let's have an example. Let's say f of x is equal to 2x plus 3 and g of x is equal to x minus 3 on 2. So now we are going to do for the two cases, and if they are both x, then they are inverses. So let's have the first case, f of g of x. F of g of x. Remember, it should be equal to x. So we are going to have 2 into x minus 3 on 2 plus 2. That is what we have. And as we can see from here, they will cancel out. So that is going to happen. Sorry, this is 3. So these ones will cancel out. And we are going to be left with x minus 3 plus 3, which boils down to x. So our first case is true. So let's take the second case. Let's have g of f of x. So we are going to have 2x plus 3 minus 3, all that on 2. So this is 2x plus 3 minus 3 on 2. So as you can see, positive 3 minus 3, this gives you 0. So we are going to be having 2x, all that on 2, and the 2's will cancel. So this leaves us with x. So here gives us x, and here gives us x, and so we can conclude. We say therefore they are inverses. Therefore they are inverses. So from here we can conclude. Remember, f of g of x should be equal to x, and g of f of x should also be equal to x. Okay, so now let's have another quick example. Let's say, okay, let's have the first question. Let's say if f of x is equal to x minus 5, and let's say g of x equal to 3x. So here we are going to find f of g of x. Okay, and then let's say also find the inverse of f of x equal to x minus 4 on 3. So this is what we have. Okay, let's take the first question. So our f of x is x minus 5 and our g of x is 3x. So here we are finding f of g of x. Remember I said f of g of x, we need to start by evaluating g of x and then taking the results and evaluating with f of x. So let's start. What is our g of x? Our g of x is 3x. So we are going to substitute it into our f of x. So that gives us 3x minus 5. That simply gives us that. And then that is all for f of g of x. And then the second part says we should find the inverse of f of x. Okay, so to find the inverse of f of x, if you can recall the steps, the first step was write y equal to x minus 4 on 3. So after that, we had to swap x and y. Okay, in this case, I'm just going to make x the subject of the formula. So here I'm just solving for y at once. So we're going to do cross multiplication. We're going to have 3y equal to x minus 4. So remember I said we are simply making x the subject of the formula. So we are going to have 3y plus 4 equal to x. So if I just turn this, we are going to have x equal to 3y plus 4. So this is what we have. And then here we can state our inverse. So to state our inverse, we're just going to say f inverse. Remember, this is how we write f inverse. F inverse of x. If it were g, we will have g inverse of x, like that. So here, we have f inverse of x, and so we are just simply going to replace this y with x. So we are going to have 3x plus 4, and that is our inverse of. Okay, so at this point we are going to have a very quick recap. So remember I said for the composition of functions, this is how it is written, that is how it is written. And remember I said f of g of x and g of f of x are not commutative. So as you can see, they give us different answers. If they were commutative, then when you solve each of them differently, we should have similar answers. But here we don't. So remember I said they are not the same. They are not equal. So that was that. And then for the inverse of a function, these were the quick steps to write. You should not forget. And remember, I said not all functions have inverses, only one-to-one functions have inverses. Remember, the one-to-one functions are the injective functions. So here, these are quick examples. So this is what we have. Okay guys, that's all for today. Thanks for watching, and I'm going to see you guys in the next video.